Hello students, welcome to the video lecture on computer organization. In the previous video lecture, I explained you about the functional units of computer, and now in this lecture, I'll be explaining about the connection between the processor and the memory. So here on the slide you can see it shows the connection between the processor and the memory. Here you can see the processor contains control unit, ALU unit. Already I just discussed about what all are the processor unit consisting of. Okay, processor unit is classified into two more units called as ALU unit and control unit. Okay, it also contains, you can look from the diagram, it also contains n number of general purpose registers. These are the registers which are used to store the data. These are general purpose registers which are named from R0 till Rn minus 1. It contains PC. PC is one more register which is named as a program counter. PC always will be pointing to the address of the instruction which has to be executed next. Assume I have a program with the 10 instructions. Okay, if the first instruction is under execution and the second instruction will be executed after this, right? So PC will always be pointing to the second instruction which will be executed next. Okay, currently which is under execution? First instruction, right? So when it is executing second instruction, immediately PC will be pointing to the third instruction, address of the third instruction. So this is the aim of using the PC. Next in the diagram you can see you are having IR. What is IR? Instruction register. Okay, it holds the instruction which is to be executed. Fine. You can see the other two registers MAR and MDR. What is MAR? Memory address register, and MDR is memory data register. See, we are having a connection between the memory and the processor. You can see the arrows. The arrows are connecting memory MAR, memory and MDR, memory and control unit. It's not connected to the rest of the other registers. Maybe ALU unit, it's not connected. Memory is not connected to general purpose registers. Memory is not connected to PC. Memory is not connected to IR. So only by means of MAR register, MDR register and control unit, the processor can communicate with memory or memory can communicate with the processor. Okay. So MAR is what? Memory access register. MDR is what? Memory data register. So memory and processor, as I told, can communicate directly only through MAR, MDR and control unit. Now we have to look at how program is executed. Any program which has to be executed should be stored in memory, that I explained you, right? To execute a program, the instructions are to be executed one after the another. If they are arranged in a sequential addresses, they will be executed one after the other. If at all any loop operation is there, then they will be executed in loop form, right? Now consider an instruction. Let's take as an example, I just will show you the instruction add lock A comma R0. Consider this instruction, and this execution of this instruction I'll be explaining. Okay, what is happening here in add lock A comma R0? Add is the mnemonic which is used for addition operation. Lock A and R0 are the two numbers which I am adding. What I am performing here? Addition of two numbers is done. The two numbers can be also named as operands. Add is the mnemonic which is representing the operation. What operation it is representing? Add. Addition. Fine. Then two operands. Operands are nothing but the datas on which the operation is to be done. Okay. So those two operands are where they are. One is in lock A and other one is in R0. Okay. Now let's discuss the steps which are necessary to execute this instruction. How execution happens. So this address which has to be executed next, the address of this instruction which has to be executed next, where it is present? It is present in PC, isn't it? So the content of this PC will be transferred to MAR. Why it's necessary to transfer it to MAR? Because the memory can only access or it can only communicate through MAR, MDR and control unit. That's why whatever is the address present in PC will be moved to the register which can hold memory address. Which register it is? MAR, isn't it? So it holds that instruction. Which instruction? Add lock A comma R0 instruction address is present in MAR now. Then control unit sends the read signal to the memory. Now memory gets a read signal from the control unit and it gets to know that it has to read. What it has to read? It will take the address from MAR. So it reads the content of the memory address which is present in MAR. So what address is present now? The address of the instruction add lock A comma R0. That's why it reads this instruction. Which instruction? Add lock A comma R0 is now read by the memory and store it in MDR register. Because it can place it only in MDR, not in IR directly. Okay. So now memory data register is holding what now? The instruction add lock A comma R0. Now this content is transferred to IR. What is IR? Instruction register, isn't it? So from here what happens? IR, the content of IR is taken and decoding takes place. The instruction within IR will be decoded. After decoding only the processor will get to know what the operation is. Why? Because it's not understanding the high level language, it's not understanding the assembly language, it can only understand the machine level language. Whatever instruction I have written, add lock A comma R0 is not a machine language. It is in assembly language. So after decoding, it gets translated to machine level language and thus the processor will get to know what it has to do. What it gets to know? It gets to know that it has to perform addition of two numbers. One number is present in lock A and other is present in R0. Okay, after decoding it will collect this. Then what it does? It has to take the content from lock A. That's why the address of lock A is moved to MAR. Okay, again control unit sends the read signal. After getting the read signal, it collects the address from MAR, okay, and then reads whatever is present in that address. In that address, which is stored in MAR, what is there? What is there in MAR? Lock A is there. What is lock A? It is the address of some memory. What is present in this? Some number is present which has to be added. So that number is collected from lock A address and moves to MAR because the data can be placed in MDR only. So data from lock A address is read by memory and stored in MDR. Okay. Now one of the data is in MDR and the other is in R0 itself. So nothing is to be taken from R0 because it is general purpose register. It can be directly accessed by ALIV. Now what happens? ALIV will add these two datas. One it collects from MDR and one more it takes from R0 register. According to the instruction, what instruction it is? Add lock A comma R0. The content of lock A, data in lock A is to be added with the data in R0 and result is to be stored back in R0. That's why the result will be stored in R0 only. Now assume that I want to store the result in lock A. That is, if the instruction is add R0 comma lock A. What I have changed? Source and destinations I have changed now. See, add R0 comma lock A. Now data in R0 is added with data in lock A and stored in lock A. If this is the scenario, then the same things will happen. Till ALIV it will be same. Addition of the two datas will be done. Now result, instead of saving in R0, it has to be moved to lock A. So what it does? If the result is to be stored in memory, then the address where the result is to be stored. Where the result is to be stored now in our example? In lock A, assume. then it has to be moved to MAR, and whatever result I want to store, the data is to be present in MDR. Then what happens? Control unit sends a write signal. Upon getting the write signal, what memory will do? It will collect the address where the data is to be stored from MAR, and it collects the data from MDR, writes the content of MDR into the specified memory location, that is in lock A. Okay, thus result is saved in address in some memory location. Thus an instruction will be executed. In this meantime, the content of the PC will be incremented and it will be pointing to the next instruction. Again, for execution of the next instruction, the same sequence of steps are to be executed. In the same manner, it gets executed. This is how instruction execution will be done and program gets executed. In the next video, I'll be explaining the next further topics. Thank you.